Grignard reagents will form alcohols when reacted with carbonyls. Let's look at the reaction. This is a Grignard reagent. This large dipole puts a huge negative charge on the carbon in a Grignard reagent. That huge negative carbon is a nucleophile. It will undergo nucleophilic attack on a carbonyl. It's very basic also, and remember it will deprotonate an alcohol. But if there's no alcohol present, it will undergo nucleophilic attack on a carbonyl, where the nucleophile comes into this carbon and these electrons jump onto the oxygen. That gives this complex where there's a negative charge on the oxygen, and of course the magnesium halide then is the counter ion. Washing with water or acid protonates the oxygen so that you then have an alcohol. Notice you're adding an extra carbon to the chain. So aldehydes, which have only one carbon attached to the carbonyl, now have two carbons. Ketones, which have two carbons attached to the carbonyl, become tertiary alcohols and have three carbons attached. Treatment of hexanal with methyl magnesium bromide followed by an acid wash. Try to figure out what the outcome of this reaction is. Well, when we have the methyl magnesium bromide, there's a large negative here so that it acts as if it's a methyl anion. This then goes and attacks right here to the carbonyl. Here's the mechanism for it. The electrons come in, hit the carbonyl, and the electrons jump up onto the oxygen. That gives us this intermediate. There's a magnesium that would be complexed with it, but this is the organic part that we're interested in. Of course, this is highly basic, and if we treat it with water, water will protonate that oxygen to give you an alcohol. Notice this was an aldehyde. Now we have a secondary alcohol, and not only that, there's one more carbon on the chain. 6 here, 7 there. So you go ahead and try it. What is the outcome of ethyl magnesium bromide with cyclopentanone? Okay, well, the large negative charge on this carbon attacks the carbonyl here, and the electrons jump up here, and then the water protonates the oxygen. We end up getting an alcohol on this carbon with the ethyl group attached. Notice you have to put the carbon with only 2 hydrogens on this attached to this carbon because that's where the negative charge was. It wouldn't make sense to flip this around or put it in the middle of the chain. It must be to this carbon. So how can you make 1,4-dimethyl cyclohexanol from 4-methyl cyclohexanone? Okay, well, let's first draw the structure of 4-methyl cyclohexanone and the reagent that you'll need. We're going to be adding 1 carbon right here and changing this into an alcohol. The reagent we need is methyl magnesium bromide. Following it with a water wash then protonates the oxygen that results as an anion from nucleophilic attack. So what should we get as our product? We will get just what we want, 1,4-dimethyl cyclohexanol.